Okay.
Thank you.
So for all of you guys who are active today, this is a special lesson just for you. And the joke of the day is Notre Dame. What's it with Notre Dame? Why are they always so good at football?
I don't know why.
Well, they have that special running back, the hunchback. Every time he wants to go through the line, he goes on hunches, and he picks this hole or that hole, and he gets through it. So the hunchback does really well for Notre Dame. Okay, the end. That was that. Candle actor, please. Okay, so now we're gonna
Encore.
we're gonna
You should say that there's a guy that follows his punches and then he won't on.
yeah, something like that. Okay. So anyway, the way you deal with this problem, first thing that you want to do is find a common denominator. So I'm going over number 42, and this is something that we haven't seen before really, and this one's a little bit different. So what you want to do is multiply this 1 by 1 minus cosine over 1 minus cosine. So if I do that, I get 1 minus cosine theta minus sine squared theta, the whole thing over 1 minus cosine theta. Well, so this is just the left side of the equation. Remember, I'm only working with one side of an equation at a time. Okay?
The one the other side of the side.
No, because what I did is I took 1 and I multiplied it by 1 minus cosine theta over 1 minus cosine theta, right? And that gives me this, right?
Yeah.
And the whole thing is now over 1 minus cosine theta because that was the common denominator. So now what I'm going to do next is I'm going to rewrite, since I have cosine over here and I have cosine down here, I have a hunch that I want to turn this into cosine because I think that I've had a lot of experience and I have a hunch that something's going to disappear when I turn this sine squared into 1 minus cosine squared theta, okay? Over 1 minus cosine theta. Yeah, because how I did that is because I know that sine squared theta plus cosine squared theta equals 1, okay? Therefore, 1 minus sine squared theta equals cosine squared theta, or 1 minus cosine squared theta equals sine squared theta. So you can use that substitution whenever you want, and a lot of times it's helpful, okay? So now I have 1 minus 1. What happens to 1 minus 1? It disappears. So now if I rewrite the top of this equation, I get negative cosine theta minus negative cosine squared theta, which turns that into a plus cosine theta over 1 minus cosine theta. Not yet. Okay? So the next thing I'm going to do is I'm going to look at this. Whoops. Don't I have a cosine squared? I'm sorry.
Yeah.
Cosine squared. So this here, because people get confused when there's all these cosines and stuff. This is exactly the same as having negative x plus x squared over 1 minus x. What can I factor out of both of these? An x. Except since I have a 1 minus cosine theta here, what I want to take out is a negative x. Okay?
So 1 minus cosine theta. Oh wait, never mind.
Why is it sine squared plus
This?
Are you just
I'm just showing you where I got this from.
Okay, I thought you were putting that one.
Okay. So now what I'm going to do is I'm going to rewrite this as I'm going to pull out a negative cosine of theta times 1 times what? Minus cosine of theta which works out very nicely because now I can cancel out those 1 minus cosine theta, and what I'm left with is where I was trying to get to is negative cosine of theta. Okay? So as you can see, the biggest problem with this is kind of it's knowing how to do the algebra. You know, knowing how to manipulate equations. It's not that much trigonometry. It's more like knowing how to play with equations and factor things and knowing how things factor and stuff like that. It's not all that much trick. So you have to be good at algebra.
That was like the problem with the whole overdesign.
There's lots of algebra. So as long as I'm here, let's look at that last example that I had. Number 17 too? You want me to look at 17? Okay, so let's, exit. Number 17. Number 17? Oh yeah, this is another kind that we haven't really talked about. So this would be a good one to review. So, factor and simplify. And so if you see something like this here, again, it's just algebra. This is like the same as having 3x squared plus 4x plus 1 over x squared plus 2x plus 1. And so this factors to, no matter factor, okay? 3x plus 1 times x plus 1, that's right? X, so 3x, and the bottom would factor to x plus 1 times x plus 1, yeah? And so these cancel out, and that's what you get. So you could just change, instead of having these x squares, they're sine squared. So 3, this is equal to 3 sine theta plus 1 times sine of theta plus 1. And then over sine of theta squared, or sine of theta plus 1 squared, or sine of theta plus 1 times sine of theta plus 1. And then you can cancel those out. And you get that that's equal to 3 sine of theta plus 1 over sine of theta plus 1. And don't do this. People, don't cross out, don't do this. You're not allowed to cancel things out when they're attached by addition, only when they're attached by multiplication.
Can you cross out? Like if you say it's
No.
3 sine theta over sine theta plus 1, that's still, you would cross it out?
If it's 3, no. If it were 3 sine of theta over sine of theta plus 1?
No, 3 sine theta over theta and then the plus 1 is
3 sine of theta over what?
over sine theta plus 1 over 1
Plus 1?
No, the plus 1 is outside of the fraction. Could you just do that?
No.
Oh, if it was
Outside the
plus
whole
1
fraction.
over there. Yeah, if it were like that,
Then you would just say it's-
yeah. Yeah, but that's not what that's saying, right? So you gotta be
Well, it's that
careful.
simple.
No, but that's as far as you can go with that. That's it. Well, yeah. Okay? So then let's just look at the last problem on your on that practice sheet that I gave you, and let's see if I can find that practice sheet or the note sheet. Where's the note sheet? Okay. File. Gotta get out of here. Where is it? AP 16. There we go. And so I wanted to look at this. There it is. Okay. So now we're pretty well versed. We're good at this. So who can tell me, establish the identity? Who wants to guess what I should do? Conjugate. Very good. So you don't multiply both sides. You just, so this one, you can, since both are the same, both are kind of the same level of complexity, you can either work with the left side or work with the right side. Doesn't matter. But I'm going to work with the left side again. So I'm going to multiply by the conjugate of 1 minus sine of theta, which is 1 plus sine of theta. So I'm going to multiply the top by 1 plus sine of theta, and the bottom by 1 plus sine of theta. So up here, so I'm going to multiply that times 1 minus sine of theta over cosine of theta. And then I FOIL this times this gives me something that should look familiar, 1 minus sine squared of theta. And I don't want to multiply this out yet. So I'm going to leave the bottom as 1 plus sine of theta times cosine theta. And
Can you write 1 minus sine squared theta cosine squared theta?
yes, that's what we're going to do. Okay? So now I can take my 1 minus sine squared, and that's why I wanted to leave this I don't want to multiply this out yet. And I just know to do that because I've been doing this for a long time, and I kind of know that you don't want to multiply. Because originally when I started, I said, oh, let's multiply this times this, and then I get cosine theta plus sine theta, cosine theta, and then I get stuck. So sometimes you want to leave it unmultiplied out, or in factor form, I guess it's called. So I could rewrite 1 minus sine squared of theta as cosine squared of theta over 1 plus sine of theta, the quantity, times cosine theta, and then what can I do? Cross out one of my cosine thetas from the top to the bottom. So up here I have a cosine theta, so now I have where I'm trying to get to, which is cosine theta over 1 plus sine of theta. Sine of theta. Okay? And that's it. Yes? Okay, so you'll have some more practice tonight, and your homework to continue with this section, boys and girls out there into taking the PSATs today, is they won't have their homework tomorrow?
No.
Okay.
Maybe they'll look at
They're
our
gonna use
website.
the-
Hey, if you listen to this video and you have both of your homeworks done tomorrow, I'll give you 2 points of extra credit. Okay, that's
I will apply one.
Yeah, we should.
Sure, why not?
Yeah.
Page 471. So it's just a continuation. 471. 10 through 18 even. 10. And you have to do the trig cut-up puzzle. 10 through 18 even. It's accessed on my website. I'll bring it up in a minute. Okay. 22 through 30 even. Even. And
I think you should just stop there.
33, 30, 33, 38, two more, 40, and 45. So I tried to assign ones that are similar to the ones that you had last night, okay? So that's your homework, and then if you go to my website, those of you who aren't here today, and those of you who are here today, I have the trig cut-up puzzle, which is kind of fun. So what you do is you go to Mr. Leader's Cutting Edge website. Where is Mr. Leader's Cutting Edge website? There it is. And you go to pre-calc assignments, and you go to Chapter 6, Analytical Geometry, Analytical Trigonometry, okay? And then you click on Trig Cut-up Puzzle. There it is. No, not magic. Trig Identity Match Puzzle. This thing right here. Right? And so you can get this, you can do this with a partner. Yeah, this is the second one. Okay? So what you have to do is cut these all out and use some of the techniques to figure out which things match up. For example, if I sip, this is pretty easy. So let me just, here, I'll do one for you guys, okay? So that you'll know how to do it. I'm not going to do the whole thing. And the other thing is the corners are there for you. Know which have to be the corners, because the corners look like this, see? So that's got to be a corner. This has got to be that a corner? That's a corner. Then you can tell which are the sides, right? Because they don't have anything. So you really, it makes it a little bit easier in that regard. But you need to show some work. So for example, let's look at like this square right here. I could even cut this square out. So you can do this just on a normal, without having a cutting edge Mobi board like I did. So with a smart board, I guess you could. Alright. So say I have this one right here. So what you probably want to do is simplify this thing right here, cosine squared A. A is like just another angle, so instead of theta, they're using angle. So I could rewrite this as, how can I rewrite cosine squared of A? 1 minus sine squared of A, over 1 plus sine of A. And this is like, this here is like having 1 minus x squared. And 1 minus x squared factors to 1 plus x times 1 minus x.
Wait, how is it like that?
Because it's 1 minus sine squared.
Oh,
so, yeah. So I can factor this to 1 plus.
Minus
1 plus sine A over 1 minus sine A. This is probably the hardest one, or these ones are like the hardest. And so 1 plus sine of A will cancel out now. And so I go around and I look for a 1 minus sine of A that matches up with this. So going back to your puzzle, where's my puzzle? You see a 1 minus sine? There it is. Okay. So that one has to match up with, was it this one?
Yeah.
And you can use, you know what this is, right? So 1 over secant, these ones are all easy. So the only ones that are hard are these ones like this. This is equal to something that you know what that is.
So you have to put them like adjacent to the one not being equal?
Yes, the ones that they equal, okay? So you're trying to make the identities match up. And you gotta show some work. You can't just, play around. Okay, so that's the end. Remember, you've heard it here. Thank you. On this or later's YouTube channel.